Question 3 is on a chi-squared test, and it's a two-way table. We can see that because we've got two different directions to the table that we've then got to use to help us to see if something's independent or not. And it even says that it's a chi-squared test for independence. So the first one, we're stating the null hypothesis. So the null hypothesis is always the independent. Okay, so they're not associated and they're independent of one another. So you needed to write something with respect to the variables being independent. So for example, the number of salad meals is independent to the position that they've got. Okay, and then the second one, you're calculating the p-value for the test. So we use our GDC for that. So on our GDC, we're going to need to create a matrix and type this two-way table in. So we go to Menu, Matrix and Vector, and Create and Create. So this is just a fancy name for a table, if you like. So we've got on our information 3 rows and 4 columns. So we don't use the totals. So 3 rows and 4 columns. And I can now type that information in. So I've got 45, 26, 18, and 6. And then for the professors, I've got 15, 8, 5, and 12. And then for the staff and administration, I've got 16, 13, 10, and 6. And I need to store that as a variable in my GDC. So I'm now going to do Control and Store. That's the blue writing here. And any letter will do. And I can test it. If I use A, it should bring that table back up for me. Now that I've got that saved, I can do the chi-squared part of it. So I can go to Menu, Statistics, Stats Tests, and it is a chi-squared two-way table. So it's this one here. And all I need to type in is that letter telling it the table of data. And that brings up all of the statistics that I might need. So my chi-squared value, if I wanted it, was 15.0187. I'm asked for my p-value, which is the 0.0201. So the p-value, and again, don't forget your 3 significant figures. So rounded to 3 significant figures, it's 0.0201. And then for the next question, state giving a reason whether the null hypothesis should be accepted. So again, the best thing to do here is just to draw a diagram. So the chi-squared curve will look something, it's like a wonky normal distribution curve. And I'm testing to a 5% significance level, 5%. So that means that my critical value is giving me an area of 5%, because that's my significance level that I'm testing to. And the area that I found was 0.0201, which is 2.01%. So the area that I found is much smaller, it's just less than half. So my value, I'll just change colour, is going to be about here. And that's my area of 2.01%. So that's like my chi-squared value. So we know that it's the critical value that I base my decision, whether to take the alternative or the original, the null hypothesis, and therefore my section is within the alternative hypothesis. So I'm going to reject the null and I'm going to accept the alternative, the HA. Now it's up to you, you need to show a reason. So drawing that diagram is enough, or if not, then you can explain that the p-value was less than the 5% significance value and therefore we reject it. So either of those explanations is fine.